Hello everybody and welcome back to Spacedock. I'm Hujuana and today we're covering the controls you need for Spacecraft, because they're a little bit more involved than you might realise due to their three-dimensional movement. Let's start with a point of reference everyone is familiar with, cars. These have very simple controls because they only work in 2 dimensions and need to be moving to steer. They have 2 degrees of freedom of movement and at minimum 3 controls: steering with a wheel in the yaw axis and throttle and brakes on pedals. Planes are the next step up since they work in 3 dimensions and as such their controls are more complex, but they still need to be moving in order to turn. This is a simplification, but at a minimum they have 4 degrees of freedom and controls that match that. Pedals control yaw, a yoke or stick that turns for roll and moves forward and backward for pitch, and then throttles for engine power. We see this setup a lot in sci-fi settings where smaller craft move around just like aircraft do, which is perfectly fine. It's a bit weird to see it on a larger craft like the Enterprise though, especially when Riker's probably only got pitch and roll on that thing there, judging by how he moves it. And that's because spacecraft need full 3-dimensional movement. They can turn in any direction at any time, and even accelerate in any direction at any time if they have RCS thrusters. So they have full 6 degrees of freedom at any time. How many controls is that? However, you don't necessarily need to have all of these degrees of freedom available. It's perfectly fine to only have pitch, roll, yaw and a throttle for regular maneuvers. So controls there can be very similar to what you'd have on an aircraft, though roll and yaw would switch their importance. It's only when you get into more complex things like docking where being able to slide omnidirectionally while in any orientation becomes helpful. Even then, it's not required. It just makes it massively easier because orbital mechanics can make engine-only docking a headache. Not to mention rocket engines are not as forgiving as they are in Kerbal Space Program. If they can throttle at all, they may not go as low as you need them for delicate motions. Or they may be so powerful it's not worth trying at all. That's why you use RCS thrusters for omnidirectional movement. But when you do that, you start needing more complex controls to manage all of those degrees of freedom. You still need to control rotation and throttle as before, but now you have to add on translation in 6 possible directions: forward, back, left, right, up and down. The real-life solution here was a pair of fancy joysticks. One controls rotation just like on aircraft, with the addition of twisting it to input yaw commands. The other can be another stick or something more like a handle, which can be tilted forward, back and side to side for those movements, but can also be pulled in and out for the 3rd axis of control. 6 degrees of motion with just 2 controls. It's even possible to get that down to just 1 control with something called a 3D mouse, which you may have seen being used in The Expanse. These are like advanced joysticks, but specifically designed and optimized for use with CAD programs or 3D art, with their movement aligning with how you move the camera in those programs. You can push it forwards, back, up and down and to the sides to pan the camera. You can also tilt and twist it to rotate the camera too. That's all 6 degrees of freedom, so you can map this straight to a spacecraft RCS system to fully control it with just one hand. The question is that wise to do? If rotation and translation are split over 2 controls, it's a lot harder to make the wrong input, but if it's combined, you do have the other hand free for other tasks. That's the method you could use for direct control over a spacecraft, but you can also just program a computer to do maneuvers for you. For that, you can use a keypad as they did on Apollo for their flight computer. You could even have a full keyboard if you really wanted. If you did that, you can also just directly map all the functions for flight onto that keyboard, as Kerbal Space Program does. But reality is not as simple as that game, and so keys with only on and off states may not cut it. That lacks the fine control you'd get with something like a physical lever or joystick. Stepping up from keyboards, you get touchscreens, and these are different since you can map all sorts of extra functions to them thanks to being able to drag your fingers over it, letting you do all the things we see in Star Trek where people power up transporters and stuff. They're even in use on the SpaceX Crew Dragon, though I don't know how much control they really give over the vehicle compared to how much is done by a computer, which is probably for the best really, given how terrible touchscreens actually are. Anyone who's used one in a car knows they're a pain and inferior to physical controls. You have to take your attention away from what's around you to go through menus and stuff to do various tasks, which is dangerous and annoying. And the US Navy agrees, since touchscreen controls don't provide tactile feedback and switching their functions just leads to confusion. So they're going back to physical controls, and hopefully the same happens with cars too, since safety ratings are being updated. There's another flaw with touch controls that's only an issue on spacecraft, which is that they don't work great when you're floating around in zero-G. And this comes directly from Chris Hadfield, and he's got some experience in the matter. The next step up in control via a computer is voice commands. The go-to example for this is naturally Star Trek, but I'm not sure if these are ever used for actual ship control. Orders are given to a helmsman instead, and I wonder why that is. Is it a deliberate anachronism to match how ships work, which I'll talk about in a bit, or just an oversight from a time when computers were instead used to compute and to get information? It's probably a combo of the two, but I don't know enough Star Trek behind the scenes to say for sure. And the pinnacle of control method is of course direct control from the brain. And there has been a lot of progress towards that in the civilian sense, in that people have been setting up things to directly control video games and the like. Good for future applications for those with disabilities, but a long way to go before people are directly controlling vehicles like that. Moving on from those, we get into the more exotic methods we see in sci-fi. Sometimes it's just fancy versions of options we've already talked about, like the weird controls of the TIE Avenger in Andor, or whatever the deal is with railjacks in Warframe. The holograms Mass Effect has are particularly interesting to me because the Codex acknowledges that these are worse than touchscreens since you can't touch them at all. They have no physical feedback whatsoever, but there are special haptics gloves and even implants to provide that feedback. Though surely it would just be easier to have a physical control if you're going through all that effort. The other part of any set of controls is the instrumentation to go with them. These tell you what state the vehicle is in, like which direction it's facing. This is particularly important in space where there's no reference points and you can be in any orientation. The best real solution to this is the attitude display, that spinning ball you see on aircraft, which also works great for spacecraft. To go along with that, you need a good timepiece so you know when to start and stop certain maneuvers. You don't want to do an engine burn at the wrong time or for the wrong length, since that means you won't end up where you want to go. On top of that, there's also extra instruments for more specific situations, like radars and lasers used to provide distance to the target for docking and landing. Visibility can also help, but due to the nature of spaceflight, it's far less important than instruments and plotting and burn execution are. As with everything, there are of course exceptions, like manual docking and landing, and for sci-fi, visibility helps for dogfights. Plus, big windows just look cool. The last thing to consider is the use of different controls for different sizes of spacecraft. Full-sized ships are far more complex, and as such, each part of ordering and controlling a vessel's movement is spread out over multiple people. The captain decides on an overall course of action, they say the destination. Then the navigator plots the maneuvers to get there. Then someone at the helm inputs the commands. On more ship-like vessels, there's also a good chance of having engineering personnel taking on the role of setting engine power. This can all be simplified out to various degrees, shifting certain roles to be done by computer or consolidated into one position. Faster than light systems can be just another part of those jobs, but sometimes can require whole different personnel and systems to do things like plot the route and activate the drive. Battlestar Galactica is particularly notable here for this, but Star Wars has often made preparing for hyperspace a plot point. What we've talked about today makes for a great foundation. There was a lot of simplifications, but now you know what controls are available for a spacecraft's RCS thrusters and main engine. Going beyond that into the more complex offerings of sci-fi with extra thrusters and more exotic control schemes is going to demand different methods of control, or at least very good computer systems to act as a go-between. Those methods can be based on what's used in real life or use the more fanciful options that science fiction allows. You can support Spacedock by joining our Patreon, where you can get our frigate and spacefighter design reference books. Alternatively, you can support us directly through YouTube by becoming a channel member. Thanks to our supporters, and thank you for watching.